Welcome to Summarize Science, where we break down complex research for everyone. Today, we are looking at a paper titled Enhancing AI and Dynamical Subseasonal Forecasts with Probabilistic Bias Correction. Weather forecasts are incredibly accurate for about 2 weeks, but after that, they usually fall apart. This middle ground between 2 and 6 weeks is known as the subseasonal timeframe. It is notoriously difficult to predict because small errors in the beginning compound over time. Meteorologists even call this area a predictability desert because model skill drops so drastically. To fix this, researchers introduced a framework called Probabilistic Bias Correction, or PBC. The goal of PBC is to learn from the past to correct systematic errors in today's models. Instead of trying to relearn physics, it looks at how models have been wrong before and adjusts them. They use 2 main components in this system, one called dBIAS++ and another called persistence++. The results are impressive when applied to the world's leading weather models. For example, when they used PBC on the standard ECMWF dynamical model, the skill levels surged. It converted negative skill forecasts into predictions that consistently beat the historical average. In fact, it improved the skill for 92% of temperature targets and 98% of precipitation targets. You can see the dramatic shift in these charts where the yellow bars represent the improved PBC forecasts. The raw model data, shown in purple, often struggles at the 3 and 4 week mark. By applying this machine learning correction, the researchers were able to turn those failures into successes. PBC is not just for traditional physics-based models, it also works wonders for AI-based weather systems. Applying PBC to a leading AI forecasting system actually tripled its skill for predicting temperature and rainfall. This shows that even the most advanced AI models still have systematic biases that can be corrected. To test its real-world value, the researchers entered a global competition called the AI Weather Quest. Their ensemble system, which they named MicroDuet, competed against 34 teams and 6 national weather centers. MicroDuet placed first for every single weather variable and every lead time in the competition. It was even the only model to significantly outperform the industry-standard dBIAS models across the board. Perhaps the most important part of this work is its ability to predict extreme events. They found that PBC substantially boosts the ability to foresee heat waves, cold snaps, and floods. For flood forecasting specifically, traditional models often underperformed, but PBC provided positive skill every single year. In these maps, you can see how PBC smooths out the errors across the entire globe. By reducing the bias in the top precipitation quintiles, they have created a better early warning system for disasters. The data shows that this framework makes hazard prediction much more reliable for decision makers. So, what does this mean for the future of our weather reports? This tool is lightweight and designed for operational use, meaning it could be integrated into current systems today. It allows meteorologists to get better results from their existing computers without needing massive new hardware. Better subseasonal forecasts will help farmers plant more effectively and help cities prepare for extreme heat or flooding. As climate change makes weather more unpredictable, tools like PBC will be vital for protecting lives and economies. Thanks for watching Summarize Science, and stay tuned for more breakthroughs.